Arc length of a curve. Find the length of the curve, y equals 1/3, 2 plus x squared, quantified, plus to the 3/2. For 0 less than x, less than 1. Okay, so first thing we should know is the formula for arc length. So this is more mnemonic than actual proof. But the idea for the arc length is you have a length like this. You have a triangle like so. This will be your dx. This will be your dy. And this will be the length of your arc as an approximation. And this length here will be dx squared plus delta y squared square rooted. Pythagorean theorem. And so we have delta x squared plus delta y squared square rooted. And we will rearrange this a little bit. We will factor out a delta x. So we factor a delta x out. We have delta x squared square rooted times 1 plus dy dx quantity squared. And then square root of delta x squared will just be delta x. And then this gives us our formula, integral 1 plus dy dx dx. And we'll integrate for x. We could go in the y direction if we wanted. We could just factor out the delta y. And we'll go from 0 to 1. Whoop, whoop, squared. And so what we need to do then is we need to find dy dx. Oop, didn't mean to take this. And I'll erase the formula. I'll remember it. You guys remember it? I remember it. Together as a team, we will remember it. Our goldfish memories combined. So if you combine a bunch of goldfish memories, does that become a school of memory? Deeper than I intended. Deeper than intended. Okay. dy dx. So we're going to use the power rule here. So we'll do 1/3. It'll be 2 plus x squared. 3/2 minus 1 is 1/2. And then we'll multiply by 3/2 here. But then we'll multiply by the product of the interior, which will be 2x. Do some canceling. Convenient canceling. And we're left with x times 2 plus x squared to the 1/2. I know that's a parentheses and that's a bracket, but it's fine. It's fine. It's okay. All right, so then we need to have dy dx squared equals x squared plus 2 plus x squared times 2 plus x squared. And then, let's see here, we have 2x squared plus x to the 4th. Okay, and that's our delta y delta x squared. Now we're going to have to integrate this. So we'll have integral. Now I'm going to change colors. Change colors. Color change. Like a chameleon. Whoop. I guess that'd probably ruin the whole camouflage technique if the chameleon yelled out, change colors, before he did it. Probably end up drawing more attention than desired. Okay. X to the 4th plus 2x squared plus 1 square rooted dx. All right, and this is a square. So we have, I think it's x squared plus 1 squared square rooted dx, which equals integral x squared plus 1 dx, which equals x to the 3rd over 3 plus x evaluated from 0 to 1. Okay, is that true? Maybe true. Okay, so we got lucky where x to the fourth plus 2x squared plus 1. You can factor that as a square. It's kind of like the x squared plus 2x plus 1, except instead of having just x, we have x squared. And it works out, did the square root thing, and we get this at the end, or close to the end. And now we will plug in values, specifically values of 1 and 0. So we have 1/3, I was going to write it 2, 1/3 plus 1 minus 0 minus 0, 0 cubed over 3 plus 0. I'm going to do one of these. Oh no, that's terrible. Wrong number. Okay. More serious. Plus 3/3. There we go. Equals 4/3. There we go. Whoop. Let's see if 4/3 is a possible answer. It is. Right here. Whoop. 4/3. So, the idea with this problem, you need to know the formula for arc length. Mnemonic is right. Okay, I erased the mnemonic. But the idea comes from Pythagorean theorem in a curve. That's not a good curve. Delta x, delta y, find the Pythagorean theorem, delta x squared plus delta y squared, square rooted. Factor out a delta x squared. Use that delta x squared as your dx. Do the integral. Bam, you have your formula. And so to use the formula, we found dy dx. We squared dy dx. And after that, we then just took the integral, square rooted, etc., and success. That is how you do in arc length.